Welcome to the series of Let's Draw Polyhedra. In this video, I'll show how to draw some simple polyhedra, and I'll also give their point group along with the faces that each polyhedra contain. This is becoming one of the important questions at a higher level competitive examinations such as CSIR-UGC-NET or even GATE, where the number of faces for a polyhedra are being asked. This video must be helpful for such students. I'll begin with a polyhedra taking vertices 4. So I'm starting with a tetrahedra, and I'll be representing 3 different orientations. Well, these 3 different orientations. In the first one, there is a triangular base where the corner is towards the viewer. In the second one, there is a triangular base where the corner is away from the viewer. And in the third orientation, there is a triangular unit which is above that connects to the below corner. Well, a small correction. Yes, now the top corner is being joined to the bottom triangular unit that forms a tetrahedra. The second orientation, as I draw, this is an edge, 1, 2, 3 edges that form a triangle. This is a fourth edge which is away, fifth and sixth. The 3 edges are away. So as we count, there are 6 edges. Again I am counting 1 and 2, 3, 4, 5 and 6. So 3 different orientations can also be seen. Coming to the number of edges, as I have already counted, these are the edges, 3 above and 3 from the bottom triangular face. Altogether it is forming 6 edges. One triangular face towards your right, second triangular face towards your left, third triangular face away from you, and a fourth triangular face that forms the base. This gives 4 faces, and all the 4 are triangular faces. Coming to the symmetry point group, the polyhedra belong to TD point group with order of the point group being 24 symmetry elements. A separate video has been made where I have shown all these 24 symmetry elements. The next polyhedra that I'll be choosing is with vertices 5. There are 2 different polyhedra, square pyramid and a trigonal bipyramid. I'll start with a square pyramid one. In the square pyramid, there are 4 vertices that form a square base and 1 vertex on top. So I'm joining that square base to the top vertex. That gives 4 edges. The bottom vertices or the basal vertices give the remaining 4 edges. Altogether there are 8 edges. I'm showing the other orientation, 1, 2, 3 and 4 edges that join the top vertex with the basal square plane, 5 and 6, 7 and 8. 2 different orientations of the square pyramid. Coming to the number of edges, as we counted them, that gives 8 edges, and there are 4 triangular faces. 1 triangular face towards you, 1 triangular face towards your right, 1 triangular face away from you, and 1 triangular face towards your left hand side. Along with the 4 triangular faces, also there is a square base. So 1 square face that is forming the base. The point group belong to C4V, where the C4 rotational axis pass from the apice. The next one being the trigonal bipyramidal one, where the vertices are drawn in a different orientations. There is a equatorial plane of the 3 vertices. Above and below are 2 more vertices that join this equatorial plane, and that gives a trigonal bipyramidal one. So let's count the number of edges in the second orientation. 1 from the top, 2 and 3, 4, 5 and 6. So 3 above, 3 in the equatorial plane, 7, 8 and 9. So the number of edges, all these top, equatorial and bottom one, they account for 9. Number of faces, one towards your right hand side, one towards your left hand side, one away from you. These are the two triangular faces that are above. In a similar way, there are also three triangular faces below. Altogether, there are six triangular faces. There is one triangular face that is in the equatorial plane, but that should not be considered because it is an embedded one. Any face of a polyhedra that is embedded should not be counted. So this gives only six triangular faces. The point group belong to D3H, where a C3 rotational axis could be found from the axial vertices. So it belonged to D3H. Well, the next one, right. After trigonal bipyramidal one, let's go to the number of vertices 6. The most common one is an octahedral geometry. Two different orientations are being represented here. The vertices are drawn in such a way that there is a square plane above which there is one vertex and below also there is another vertex. From the top vertex I am joining the square plane. Later on the bottom vertex will be joined to the square plane. Now as I draw in the second orientation, let's count the number of edges. This is the first orientation. The second orientation is a side view. 1, 2, 3 and 4 edges above, 5, 6, 7 and 8 edges in the square plane, 9, 10, 11 and 12, altogether 12 edges that are present in octahedra. Right, so these are the edges that we counted. This account for 12. Number of triangular faces, one triangular face towards you on top, one triangular face towards your right, one triangular face towards your left and one triangular face which is away from you. These are the four triangular faces on top. In a similar way, at the bottom also we have four triangular faces, altogether making 8 triangular faces. Since every face is a triangular face, we can call it as a deltahedra. There is a square plane that is embedded, therefore it should not be counted, and it belongs to OH point group with order of the symmetry being the 48 symmetry elements. And that's octahedra with 12 edges and 8 triangular faces. Point group is OH. The next one being the trigonal prism. 3 different orientations are shown, and in every case I have taken 2 triangular units, and these 2 triangular units must be drawn in such a way that they have to be eclipsed to one another. This is one triangular unit where the coordinate is towards you. A second triangular unit, again the coordinate is towards you, hence both are eclipsed. This is a second orientation, one triangular face where the coordinate is away from you. A second triangular face, here also the coordinate is away from you, and that both triangles are eclipsed to one another. The third orientation is a sideway view. As you can see it from a side, two triangles are eclipsed to one another. Then we have to join these two triangular faces. So that is one connection, second connection and a third connection. As we draw, you can also count the number of edges. One triangle gives 3 edges, second triangle gives 3 edges, and the two triangles are being joined with 3 more edges. So let's join these two. Yes, that completes the joining. So number of edges as we counted while drawing, 3 above, 3 in between and 3 at the bottom, altogether making 9 edges. Number of faces, one square face towards your right hand side, one square face towards your left hand side, and another square face that is away from the viewer. 3 square faces. There is a triangular face above, there is a triangular face below. Altogether there are 5 faces. Different orientations can also be seen. Out of these 5 faces, 3 are square faces and the other 2 being the triangular faces. Well, with 5 faces, trigonal prism belong to D3H point group where the two triangular units are eclipsed to one another. It belongs to D3H where the C3 rotational axis pass from the center of the two triangular faces. That's trigonal prism. And for vertices 6, we also have one more geometry, which is trigonal antiprism. For trigonal antiprism, there are two triangular units that are staggered to one another. When we draw two triangles that are eclipsed, that gives trigonal prism. In this case, when the two triangular units are drawn staggered, that gives trigonal antiprism. The strategy is to join the top corner to the bottom corner of the two triangular units, top to bottom, and then bottom to top, top to bottom, and again bottom to top, then to the bottom corner, and later to the top corner. So as we count, there are 3 edges on the top triangle, 3 edges in the bottom triangle, and 6 edges in between. Altogether that makes 12 edges. Triangular face, as you can count, well, right, these are the some triangular faces that I am representing. Some are towards you, some are away from you, towards your right and left. There is also a triangular face at the bottom, one triangular face above. Altogether there are 8 triangular faces. So this gives 8 faces, and all the 8 faces are triangular faces. Since the two triangular units are staggered to one another, this will generate a D3D point group. The symmetry point group is D3D. Well, this is trigonal antiprism with 12 edges and 8 triangular faces with a D3D point group. Well, in my next video, I'll make some more polyhedra, and I'll also show the number of faces that it contains along with their symmetry point group. Hope you like the video. Thank you.